Now that we've seen what a GCF is, let's talk about how factoring is going to work for us. Factoring is really the process of taking something and writing it as a product. And you can do this with any number, and this will also turn out to work on expressions as well. So we know that if you had 6, that would be 2 times 3. You know that if you had 15, that would be 3 times 5. What I've just done here is taken these numbers and broken them down into factors, and that's all factoring really is. It looks a little different when we use expressions, but it's the same idea. Factoring is very powerful because it allows us to take very complicated expressions and break them down into easy components that will make algebra a lot nicer for us. Of course, we use the distributive property to go the other way, so you have AB plus AC. All we're really doing here is the distributive property in reverse. We're just going backwards in this chapter. We're going from the right to the left here. So when you do this, you always want to put your GCF in front. And you want to divide each term by that GCF. And the remnants of those divisions, those quotients, will go into the parentheses. So let's take a look at some examples. Example 1 gives us 9x to the 4th minus 12x cubed plus 6x squared. We need to figure out, first off, a number that all of these are divisible by. Well, we can see they're all divisible by 3. And then if you'll remember, the GCF says to take the lowest power of each variable. So in this case, x squared. And factoring is really just the process of division, because when you're breaking something down into factors, you're just undoing that multiplication that made it. In the case of this, what I'm going to do, now that I have my GCF, is just factor it out, which is really, again, just division. So we're just going to divide each term by 3x squared. Remember, you do have to get every term, and this is going to affect both the coefficients and the exponents. For the coefficients, though, it's really easy. 9 divided by 3 is 3, 12 divided by 3 is 4, 6 divided by 3 is 2. And then for the x's, you just subtract the exponents. So here you get x squared. Here you get x to the first, but there's really no need to write the 1. The signs stay the same. And that's actually it. So you just look for the biggest thing you can factor out and divide all 3 terms by it. But you have to be careful. You still have to leave the thing you divide by. You still have to leave your divisor on the outside. For example 2, same exact idea. We're taking out 7. Because all 3 numbers are divisible by 7, you can take out 2 a's and you can take out 4 b's. Again, look for the lowest power of your a's, which is 2, and the lowest power of your b's, which is 4. And again, we just write the remnants in parentheses. So here we'll have 3a squared b minus 2. Again, I'm just dividing my numbers. 21 divided by 7 is 3. 14 divided by 7 is 2. 7 divided by 7 is 1. And I'm subtracting the exponents, so I'll have a single a in this term. You can write a to the first, but I would just leave it as a. We have 3 b's left over, plus 7 divided by 7 is 1. Again, there's no need to write 1. And there's no need to write the a's either, because we have a to the 0, which equals 1, and b to the 0, which equals 1. Now, you have to be very careful here. When you've divided everything out, because this is division, and anything divided by itself is 1, when you divide everything out, when your GCF matches one of the terms, 1 is what's left over. You'll never ever get 0 as a result of factoring. So just remember, if you factor everything out of a given term, you have 1 left.